interdisciplinary talk. This session topic is CIM-enabled quantitative view assessment in architectural design and space planning. I'm Vikrom Laovisutthichai. I'm presenting on behalf of the iLab, Faculty of Architecture, the University of Hong Kong. The team includes Maosu here, Professor Frank Xue, Professor Wilson Liu, Mr. K.L. Tam, and Professor Anthony Ye. Maosu is responsible for the technical part. He will be with us to answer your questions. I will start with an introduction, followed by research method, our proposed model, case study, and discussion and conclusion. First of all, greetings from Hong Kong with a great view of the city and numerous high-rise buildings. But do you wonder what the view would look like if we were the occupants of these buildings? These are some examples. If you look at the view of the harbor, the mountain, and the city one by one, you will see that the view can totally change your feelings. Numerous studies in psychology, physiology, and urban health have found that these characteristics of the view outside the window influence the occupants' well-being, building comfort, and working productivity. So architects must maximize the benefit of good view or good surroundings during the design process. Now, let's look at how designers deal with the view right now. This is an example from my previous project. Let me have my report. Yeah, here. At first, the view evaluation starts from a real-world site observation, surroundings exploration, and using camera or drone to capture photos in every level and direction. Then, the design team gathers information such as photos and maps before doing a manual analysis. The process is really time-consuming and labor-intensive and also costly. It also highly depends on designer perception and perspective without any automatic tool to help. So recently, simulation methods like process modeling has been adopted in architectural space planning. Typical methods include projection, ray tracing on handmade models, and fisheye lens. It is a kind of quantitative analysis, yes, but designers still have to process the modeling step by step, which is still time-consuming, still unscalable. Its outcome also has insufficient details. That's why we have to find another choice. Currently, with the advancement of remote sensing and 3D reconstruction, the view assessment based the existing photorealistic city information model also has a high potential to help increase automation and accuracy. However, this potential has not yet been realized in both research and practice. So this research developed a model to which CIM can be extended to assist view assessment in architectural space planning. We want to figure out how CIM can be fit into the existing design process. To answer this question, this research comprised 5 stages. It started with literature review and discussion with practitioners to understand the current practice. Then we defined the critical challenges. The third stage was to brainstorm the resolution, which was to develop a CIM-enabled view assessment model. The fourth stage was mainly about developing CIM as an assistive tool. Finally, the proposed model was validated and improved through a real-world case study implementation in Hong Kong. By doing that, we generate the new view assessment model. It is the integration of simulation-based view assessment and traditional view assessment before using the results in architectural space planning. So let me explain these 3 items one by one. We still start from the traditional view assessment. It remains the same, including site observation here, taking photos, collecting maps and other information, and then analyzing it manually like here. The second one, the simulation-based view assessment can be done simultaneously. The basic input include here, the view criteria, 3D photorealistic sim, and also 2D site. Here, we use nature view assessment as an example. We first register 2D site here with the 3D sim. Then we determine the site and generate the view site sampling. Then the camera function of the 3D platform is used to capture here the surroundings view at the sample site. By using deep transfer learning, the images can be segmented into nature and construction groups. Also, the natural elements within the photo can be quantified automatically. The result from that one, from the traditional and simulation base, can be used throughout the design stages. For example, here, the building form and envelope design to maximize the goodwill, or placing living, dining, and other important space close to the nature view. And the last one, the furniture arrangement to let people sit and enjoy good view outside. To validate this model, we implement it into the case study of the Parkview campus, the University of Hong Kong. The experimental environment is as shown in the screen. In this case study, our team started with traditional site observation, of course. We faced many challenges there because of the complicated site terrain and surrounding. We could not capture the view from every direction and also every level. Some photos could be taken only by entering surrounded building. It was indeed tedious and time-consuming for us. All data, including photos, map drawings, were then used for the traditional analysis. After all, here we know already that some directions or some levels are blocked by high-rise, high-density constructions, but the exact level or exact angle to improve the detail reside remain unclear. So we use simulation-based assessment here to help by selecting the criteria, registering 2D site with the 3D sim. We pre-processing the data. We capturing the photos inside the 3D platform, and we segment it and also index it. Here is the result on your left-hand side. Architect can use this quantified result during the architectural space planning. For example, here in the higher part has a high nature view index. So this part can be placed by, for example, living room, dining room, meeting room, which to enjoy the good view. But here, the lower part, you can see from like 10 to 25 meters has a very low nature view index. So this area can be used for service, back of the house, and some other things. The results also show that here, the north or the northwest part here is blocked by another building. So it can be vertical circulation, lift or stairs, which are not required at goodwill. By doing this, we can maximize the benefit of goodwill. So what do we learn from the model and this case study? We firstly reviewed difficulties in physical site visit and manual analysis, which support our proposal. Then we confirm that SIM capabilities to manage and analyze a large amount of information, and to be a less expensive virtual platform supporting view assessment in architectural design and space planning. Designers can use its outcome to confirm the qualitative result from physical site observation. The quantified result also give designer more detail to facilitate precise and rapid decision making. And one of the most important things It can also be inferred that the integration of traditional and simulation-based approach transform the view assessment process from qualitative to mixed method, combining qualitative and quantitative data. This research also fulfilled the industry demand by developing CIM to be an assessive tool, with also practice examples. However, this research has several limitations. The proposed model is especially efficient for a site renewal or design within a less change complicated environment and areas like Hong Kong. Also, a view is just one of numerous factors in architectural design, so we must weigh and balance with others. Finally, we see our proposed model as a part of generative design, where computational intelligence can automatically generate floor plans from project conditions. So the next step is to integrate our model with other criteria and tools to advance this further. So thank you very much for your attention.
Thank you very much. I decided I was going to turn my camera so you can see the view from my house.
Wow,
hopefully,
it looks good.
Hopefully it scores really well. I don't know if it scores well, but I think it's okay.
Yeah.
I do enjoy the view. So thank you very much. Do we have any questions from the audience? Both are nice views. Yes, thank you. I do have a couple of questions. At the moment, you don't have any integration with building information modeling per se, but that's something that could be done, right? Like, because you have the semantics from the BIM model, and you could say, let's do some sort of sketching or conceptual design, and then from this do an assessment using your tool, right? So you could automatically extract the height, the type of room, the size of the windows maybe, or stuff like that. Is correct?
Yeah, it's correct. Yeah. Thank you very much for this very able suggestion. Yes, it's correct. We see this as only the first step, or only a part of our future, which is to combine with other criteria into the generative design. And of course, we have to make a good use of BIM for sure for this.